Okay, this is the video solution for homework for the midterm problem number one of lab 54. So you're given a part like that, and you are told that these end faces are fixed, clamped, okay, and then uh, you raise the temperature of the entire structure above the room temperature by 400 degrees Fahrenheit. So hypothetically, if the temperature of the room was 468 degrees Fahrenheit room temperature, and then the temperature of the part at which we analyze it is going to be 400 plus 68, okay? 468. If the room temperature was zero, in the fridge, then you raise it by 400, it's going to be 0 plus 400. The difference between the temperatures that you specify on the part and the room temperature should be 400 degrees Fahrenheit. You're asked to use the most appropriate element in this problem. 99% of you are going to be using solid elements, which is perfectly okay. That's fine. But there may be a 1% who does this thing with shell element. As long as you do it correctly, we'll give you full mark. Okay. Now, it says use all planes of symmetry, and if you look at the setup of the problem, uh, you need to take you can make a vertical cut and a cut through the length of this, so 1/4 of that model. You can make the entire part and then cut it, or you can make 1/4 of the model as you see fit. So, well, why not? I'm going to make 1/4 of the model. Okay. All right. The one other thing is you're asked to make sure that there is a local mesh definement around the hole. Okay. So let's do that. Part file. Immediately, I'm going to save it, and I think I'm going to call that thing new folder on desktop, and I'm going to call this thing lab 50 midterm midterm lab 54 problem one. Okay, let's do it. All right, and as I said, I will make 1/4 of the model to begin with. On that plane, I will sketch. Now, if you look at your geometry, it looks. Why don't we do something like this? Okay, so why don't I make two arcs here? One like that. And we will clean it up. Okay, we will clean it up. And another one like oops, and another one like this. Okay. Yep. This one actually I want it to go all the way down here. In other words, I want this point to be on the line. Control that point and make it coincident. And there are different ways of doing these things. So you do it the way that you like. Okay. Now, yep. So the rest of the problem, we complete it like so, and like so. And we're going to close this top line. Okay, now let's put some dimensions. Let me see now. When I look at the dimensions of the problem, it looks like the difference from here, the distance from here to there is 4 inches. So let's do that. From here to here is 4 inches. Okay, fine. This radius is 1. 1. Okay, that radius is 1. Okay, and this radius is, that's 2. 2. And this is it. Yep, that is your model. So exit, pad it. I said that I'm not going to I'm not going to literally cut it myself with the saw. I'm going to make half of the 1/4 of the model, so it's going to be 0.5 inches. I could have padded it with by 1 inch and then cut it in the middle. I decided not to. There we are. That is your part. Okay. I'll just make sure that we didn't make a mistake in the dimensions. I don't think so. Uh, yeah, looks okay. This seems to be the thing that we have. Yeah. Okay. Yeah. All right. So let's put it in the isometric view. There we are. Oh no. There. Okay. Let's make everything out of steel. Everything is made out of steel. That's what you're told. Metal, steel on the part. We say okay. And now we're going to go to generative structure analysis. Katia immediately measures this thing. We are asked to make sure that there is a finer mesh around this hole. Okay, so let's do this. Model manager, second toolbar from the left, local mesh size on there. I don't care what the size is, I want to make sure that you can do it. So here I put down 0.1, which is very tiny here. Okay, the actual number doesn't matter. If you can do it, you get full mark for that. Right click, mesh visualization. Oh, you can see that. Yep, very good. Deactivate this block, deactivate the mesh. All right. Now we're told that this end is clamped. And let's put surface slider on planes of symmetry. So we have a surface slider. This bottom is a plane of symmetry. This is a plane of symmetry. And that is a plane of symmetry. And we say, okay. So this has really 3 planes of symmetry, okay? Now, the load is thermal load right here, temperature field. You click on it, and it doesn't matter what you pick, you always select the whole thing. That's the body load, basically. And it says 400 uh, plus room temperature. Now I know what the room temperature is, 68, and if you wonder how, as soon as you click on this temperature field, an environment branch opened up here. Double click on it, and it tells you what the room temperature is. 68, 68.018. So you add this thing to 400, you get 468.018. Is that what I had there? I'm not sure. Let me double click on this. Yeah, 0168. Yeah, that's okay. 0168. Fine. As long as you write 468, you're fine. Okay, so let's save the analysis. File, save management, analysis, save as. In that same folder, 54, this is the default name, analysis 1. Say okay. Of course, for submission, for marking purposes, you have to put your student ID number and last name in front of that stuff. All right, and then we're going to run it. And this is it. Here's the deformation. It just grows like that. Okay, let's look at the von Mises stress. And needless to say that you have a big stress here popping up because this is clamped. It's going to push on it, etc. But anyway, right there. This is what we got. Okay, so that takes care of this problem, and I'm going to stop the recording. Where is it?